Hello, I'm here to talk about our capstone project, the Spider Sense. My name is Idris. Unfortunately, my group mates couldn't be here with me today, so it'll just be me explaining. So hope that'll be okay. So as you can see here is a little logo and mockup we've done. Okay, so let me first talk about the reason how we came to design this project. So one of our group mates, he used to volunteer with deaf people a lot, and he started to think that we kind of take hearing for granted. So we started thinking about what hearing meant to us. So we realized it keeps us safe. It's a tool for communication. So for example, you're walking on the street and you hear an alarm or you hear a car honk. That keeps you safe from knowing that there's a car coming in your way. Or you would talk with someone and you'd know who you're talking to by where the sound is coming from. So this sort of encapsulates the whole concept of sound localization, or being able to tell where sound is coming from. So currently for deaf people, the current object that they use is a hearing aid, which, as you can see on the diagram we have here, a normal person will be able to hear all the sounds where they're coming from, whereas a deaf person with a hearing aid, while it works, they can hear, but they can only hear all the sound appears to be coming from one direction. So we aim to fix this. Okay, so now let me talk about our project. So what we designed essentially is a way to sort of simulate the sense of sound localization. So we took, as you can see in the bottom diagram here, I don't know how fast it'll point out to you guys, but so we took a vest and we surrounded it with microphones, so 4 of them. The diagram here shows more, but we had 4 of them. So, and we used the principle that sound will travel at a specific speed, and that if sound travels at that speed, it'll hit one mic first and then the next later at a certain time. So we can use this to calculate the angle of where the sound is coming from. So we took the sound data, amplified it, filtered it, all that kind of stuff, and provided this calculation here. And for feedback to the user, what we did was close to the mics around the torso sort of area on this vest, we attached motors to vibrate in the direction that the sound is coming from around in a ring. As well, to make it easier to see, in the top right corner, we added a GUI, which is connected to the sensor, which will visually show on screen the direction of where the sound is coming from. So here we'll show, here's a video demonstrating our project working. So you can see we have the vest over here. We have all the parts. We wish we could have printed a PCB to make this whole thing smaller, but we couldn't really do that. So in this video, you'll see my group mates making sounds, and the sound direction appearing on this GUI on my laptop. So, and I'll say again, the motors, as you can see down over here, would be vibrating if the user would be wearing a vest, and we did confirm you could tell which direction the sound was coming from. So here are some pictures. Here's all the circuits we used in the microcontroller. Then we used the battery to power it, so it could be wireless in the future. So the microphones are on the collar area up at the top, and the vibration motors are on the waist. So as you can see, we were able to pinpoint, if I go back, the GUI around 8 different directions of where the sound is coming from, which is around 45 degrees of accuracy. And so so in conclusion, I'll talk about some stuff we learned when doing this project. So we encountered a bunch of different difficulties when trying to put this together, with stuff not working, the parts not coming in as we expected them to be. So we found the best way to sort of avoid this is doing rapid prototyping. So constantly building, then testing, then building, then testing to make sure every single part works, and potentially designing new features or new parts or new segments that would replace the parts that weren't working. As well, we were able to finish this project much earlier than we expected because we were able to all split up the workload and then combine it together in the end, which I have more point on segmentation here. So in the future, if we had time to develop this further, we might develop a phone app, as you can see over here, you could turn on and off the microphones or the motors, maybe change the sensitivity, maybe determine what kind of sound is coming through. The possibilities are kind of endless. So we hope that this sort of proof of concept shows that this thing can be done. It could be useful to somebody who is deaf and to be able to determine the direction of the sound. So thank you for listening. That's the Spider Sense.